So today we will solve this question topological sort. So this is a graph question, a directed graph question, and so we will go through the question. So given a directed acyclic graph DAG of vertex V and edges E represented as a 2D list of edges where each entry denotes a directed edge from U to V. So we have to return the topological sort for the given graph. So what is a topological sort? Topological sort means it is there that it is a linear ordering of elements in a directed acyclic graph such that for every element there is a direct edge which has a direct edge from U to V. The vertex, that U vertex, should always come before V in the ordering. Okay, so like think of this like a scheduling task where some tasks must be done before others, or like your curriculum in academics, right? That you have to go through these all subjects to clear the uh, other subjects or the upcoming subjects, right? So there is a concept of prerequisites. You can think of this it like this way. Okay. So now the question is asking that we have to is there a topological sort or not? So and if it is there, then we have to return true or either false. And also with that we have to return the uh, vertex as well, whatever the vertex we have captured so far. So the name itself says that it is a directed acyclic graph, right? So what if there is a cycle? Acyclic means that it does not contain a cycle. So what if? So my question is, what if there is a cycle, right? If there is a cycle, if the cycle is present there, then we can say okay. If cycle is there, then topological sort is not possible, and else it is possible. We have to return the element that is there in the topological sort. Okay. So this question breaks down into simpler terms. What? So first thing is that we have to check if there is a cycle or not. So this is not a topological sort question. This is a normal cyclic detection question. Cycle detection in undirected or directed graph, right? So there it is a directed graph. So we have to change our methodology to directed. Previously, I solved for the undirected graph, cycle detection in undirected graph using BFS algorithm. So in this there is a directed graph. So we have to do the same thing using undirected directed graph right now, right? So let's go with the code, right? So the first thing that we do is like, this is same as what we did in undirected cycle detection, right? Cycle detection in undirected graph. The first thing that we will do is get the adjacent list, right? So since this is a directed graph, so we don't have to create another edge from V to U. We just create an edge from U to V because this is a directed graph, right? So now we are done with that our adjacent list. Now what we have to do? So I said we are going with the DFS approach here for this problem, topological sort. So what we have to do is we have to detect this cycle and get the result, right? So what comes there? So for the DFS, one thing is for sure is come is what is that? Yes, is visited, right? So we have to keep track of the nodes that we have already visited, right? So that we don't have to visit them again and again, right? And one more thing is, okay, so we know that if there is no cycle, there is topological sort. We have written the vertices, and if there is a topological sort, then there must be a cycle, right? Also, there must not be a cycle, right? Yeah. So, so, so what should be the intuition here? Like how we can uh, get the how we can proceed to the approach, right? Proceed to the solution that we have to get, right? So the solution demands us the uh, vertex that is not forming a cycle, right? So to like you know what is there in this? The basic thing is like we had to get or we have to build a array of what? We have to build an array of the path that we have visited, right? So simple, right? We just have to create a map to the path that we have visited, right? Whatever path we have visited, we have to just create a map for it. Same like is visited. Okay, if this node, so there are so many paths, right? In a graph, from zero we can go to anywhere. Not anywhere, like yeah, given as given input, like from so in this example, suppose. So focus on 4. So 4 is going to 0 and 1, right? So there are two ways that 4 is going, right? 0 and 1. So this way, or suppose there is a cycle, right? From 4 we go to till 1. So this is a path. So that path we will include in this path array, right? Or if there are more paths, so suppose 4, 2, suppose there is a edge from 4 to 2, so 4, 2, 3. This is another path. So if so, there are so many paths, right? So as per the topological sort definition, the definition asks us that you should come before v. Okay. So now the path is done. Now we will do the DFS for every vertex, right? So if DFS is there for the ith node, adjacent list is visited, right? Path, then okay, so we have the vector here, right? So vector and topo. Topo. If this is the case, then we should return what? If DFS is true there, so what it means that we have detected the cycle. So we will return null because cycle does not guarantee. So cycle does not. So it is impossible to get a topological sort if there is a cycle. Okay. So we will return an empty array, right? Now we get the elements, right? So we will return topo. Okay. So I am just returning topo here, right? We will discuss some things regarding to this line 25th. Okay. Now we will go with the our DFS approach, bool DFS. So what is there? Node, else. Other than node, we have this adjacent list. Then we have is visited, right? Then we have cycle, sorry, not cycle, path. Then we have the topo. Okay, so the first thing that we do is mark the node as visited, and if we have already covered that path for the node, also mark it as true, right? So this is done. Now traverse the neighbors of that node, right? So if not is visited, if the neighbor, we did not visit the neighbor, then check if DFS is possible or not for that node. So node is neighbor, right? Adjacent list is visited, right? Path and right topo. If this is the case, then return true. Else if that path is already there, right? If that path is already there, suppose the path of that neighbor is true. Okay, so now what it says, so this uh, condition is saying that we had this path already for that node. Again we came along all the way to this node again, right? So what is this trying to tell you? That we have detected a cycle, right? So we will return true here. We have detected the cycle detected for this case as well. Okay, uh, so now we got the cycle detected, and if the cycle is not detected and the first time we are visiting the node, okay, so we will set the uh, path to that node as false, because okay, we are done with this path. Now we will go with another path. Okay, and we will push the element in this tuple, sorry, push back node, and then return false, right? False, right? So now we will run this. Let's see what happens. Let's check if it's coming right or not. Okay, for the first test case it failed, right? Could be the reason. Logical sort list, get registered. Okay, so right here we have to check if it is visited or not, right? Always check for that node if it's visited or not. Again, compile and run. Check. Again, there is error. Now what happened? True, false. So now the thing that was the thing that was I was saying earlier was, so let's focus on this line topo, right? So we know that the answer that will come here is in the form 0 1 3, right? Like for this case it starts on 0 1 2 3 like this way, okay, but the expected answer is 3 2 1 0 1 2 3 0. So 0 is at the end, right? So it's like decreasing, or we are reversing the array, right? So here we have to write reverse topo dot begin comma topo dot end. Now let's check if it's running or not. All things are, I think, correct. Yeah, so we'll try to submit it. So like I said earlier was that it gives the answer in pre-order traversal, right? Yes, so this is our final test case passed. So okay, we are done with this problem. If you guys understood this problem, then it's well and good for you. If you don't, then please write down in the comment section what problems you are facing. Mm, and like for the time and space complexity for this algorithm, it should be big of v plus e. Okay, time complexity would be big of v plus e because we are uh, traversing the edges as well as the vertex, v vertex, right? And the space complexity is also v plus e because we are building a additional list of from edges, right? And also the recurrence track of DFS is containing the vertex V and the edges E, so yeah, V plus E. Thank you.